securing the state file. This is actually the first thing that everyone always does, and the reason why is because the state file, as you already know, is plain text JSON. There's nothing secure about it at all. It's just a state file that's JSON, and you can't. And oftentimes you can't prevent secrets from making their way into the Terraform state file. It's there. It's out in the open, and if anyone has access to your state file, you can kiss your secrets goodbye. Now, there's 3 different ways that you can secure your state file. Number 1, you could just get rid of as many secrets as you can, which is actually surprisingly effective because there's a lot of secrets that people don't need in their Terraform state file that they're putting in there anyways. So when you're designing your workspaces, your new projects, you want to make sure that you're not putting yourself at unnecessary risk by putting in secrets that shouldn't even be there to begin with. Then you have least privilege access control, which kind of goes along with the remote state storage, that you want to have your state file somewhere secure and you don't want it on your local computer. You want to control who has access to that state file. And of course, for remote state storage, you want to make sure that it's going to be encrypted at rest and encrypted in transit. So let's talk about the first point here, which is removing unnecessary secrets from the state file. I can't even tell you how many people I know that they just put all the secrets that they have access to in a workspace without even thinking about whether they need these or not. So you should always think about what secrets you're putting in the state file and what isn't really needing to be there. And sometimes it's not obvious, but you may have to re-engineer some things, but it's definitely worth the effort. Because again, the fewer secrets you have in your Terraform state file, the less you have to lose in the event of a data breach. So in order to minimize the number of secrets in your state file, you have to know a bit about what can actually store stateful data. And I was actually this kind of changes from iteration to iteration, but currently the different blocks that are able to store information in your state file include resources, data sources, and output values, which I was actually a little bit surprised about output values because I didn't realize that output values actually were able to store information in state, but they do. And that's because you can use the Terraform provider as to get the outputs from other Terraform state files, which means that the output also has to be saved. So that was a little bit surprising, and that just goes to show you that you probably don't want to be putting anything too secret in the output values either. So besides these different configuration blocks, we still have the possibility of leaking information in other ways, but again, we're going to be talking about that later, so that's not the concern for right now. The AWS database instance is a very traditional example, I would say, because this is going to be part of most people's stacks, having some kind of database, and the minimal configuration for this database would be something that looks like snippet 12.1, in which case you have a username and password, and you set those probably through variables, and you think, okay, well, that's going to be good, right? Well, obviously, or maybe not so obviously, but the username and password, anything you set as an attribute for your database instance, so if this is my database instance, anything I set here is going to be passed also as an output. So it's not there, plus any computed attributes. So if these are my attributes, I can't even draw right now, then it also gets passed out here. So username and password are going to appear as outputs, and that means it gets saved into the state file. So for example, right here, we have just a snippet of code that comes from a state file that happened to be created as part of this AWS database instance resource. And you can see that there's all these different kinds of things. But notably, password is set and username is set. The rest of these are going to be either computed or other input attributes. But you can see that if someone just had access to your state file, then they're going to have access to your username, password for this particular database instance. And that may not be a problem, you think, but there's other kinds of resources that also could be, because what if your database was behind a firewall that you couldn't access it on the public internet anyways? Well, that's one form of protection, but again, you don't want to be making yourself more vulnerable than you have to be. So the state file definitely needs to be somewhere secure and not available to just anybody that wants to read from it. Less obviously is something like a AWS Lambda function. And for anyone that's used AWS Lambda function, it is a serverless function. It's a serverless function in AWS that lets you run code without worrying about servers. And notably here is that this would be considered like an application that runs, and maybe you put this behind an API gateway or something like that. Maybe you have some kind of event that triggers it. But let's say that this AWS Lambda function needs to be able to talk to the database that we created before. And we can't really avoid having username and password, as bad as it is to have these in a state file. You can't really avoid it. If you want this database and you want to create it with Terraform, you're going to have to accept the fact that password and username are going to be in your state file. For the AWS Lambda function, on the other hand, it doesn't necessarily need username and password set as environment variables. And in fact, I'm actually going to put a little red X here because let's say you don't want that. There's better ways to be able to get information to connect to your database than by passing it as username and password and as environment variables. And the reason why is because anyone that has read access to your AWS Lambda function through the AWS console is going to be able to just see your secrets. So here's a screenshot from the AWS console, and you can see that you got read access to this Lambda function, then you're able to read password and username. There they are, Hunter2, and then admin, because apparently the other one didn't work. Now, I do not like to have my secrets exposed as environment variables. I think that is a very lazy way to do programming. I think that you need to, especially for your application layer, you should think more dynamically. You should think in a least privileged manner, so that the Lambda function should have an IAM policy that allows it to read secrets from some kind of secret store, but not be configured as part of the infrastructure deployment using environment variables. I think this is very bad because not only does it show up in the state file, but again, it also shows up in the console, so that anyone that had access to read your Lambda function through the console would be able to see your username and password right there. One of the easiest ways to do this dynamic secrets provisioning is with AWS Secrets Manager, which is kind of a secrets management service that permits rotating, managing, and retrieving secrets. And GCP and Azure have their equivalents. And in fact, it's a competitor with Vault as well. I don't think it's as good as Vault, but it is definitely convenient if you're already working with AWS. And the way that you do that is you just give it an ID. So rather than passing in the username and password directly to the Lambda function, remember this is your application layer. So we're deploying the infrastructure, and then on top of that, we're deploying the application layer. So this down here is the infrastructure, and then right here is the application layer. So this may be unavoidable to have secrets, but the application layer definitely doesn't need secrets. It just needs the permission to be able to get those secrets from somewhere else. So maybe you have something like Vault, or maybe you have a secret manager, but whatever you have a least privilege policy that allows the application to read from the secret manager store and then utilize that. And it's a dynamic secret. It's good because then you can enforce different kinds of policies. You can have rotation of secrets and so on and so forth. And if you were doing this with containers, it would be exactly the same, except maybe you would use like a container, a service mesh, instead of using a Lambda function with AWS Secret Manager. An example code, in case you were interested, of using AWS Lambda with AWS Secrets Manager, is a very, very simple one. This is written in Go, and I just declare the client. So this is the Secret Manager client that uses my credentials to talk to the Secret Manager with the ID that I pass in as an environment variable. And then here you can just print that secret, use it in some way. So now, as part of my infrastructure deployment, I'm not passing in the username and password. I'm just consuming the ID, and then I'm doing something with that ID. That ties in very nicely with the next part, which is least privilege access control. Because remember, this Lambda function, the reason why that it works is because we're enforcing a least privilege policy. So that Lambda function is going to have something that says, okay, you can read this particular secret, but that's all you have access to. You don't have access to delete secrets or change anybody else's secrets or read anybody else's secrets. You only have access to read that one particular secret, and then we can handle versioning and so forth. So least privilege access control is definitely a good thing. You should always have least privileged for your deployments. In fact, one thing that I would recommend is when you're deploying Terraform for a particular workspace, you should try to use as least privileged for your deployment role as you can. You don't want to be using an admin role for deploying all of your workspaces to either AWS or GCP or whatever. You don't want to use an admin role, because then whoever has access to do a run on that workspace can deploy whatever they want. They can deploy EC2 instances that just appear for a short time and then mine Bitcoins and go away. It's not a position that you want to put yourself in. You should consider what you want that deployment role to be able to do, and then do that. Now, I understand that's very difficult because Terraform hides so much from you. You know that it's going to do a create, you know it's going to do a read, you know it's going to do an update, you know it's going to do a delete. You may not really understand what goes into that. I did write a little program to be able to parse AWS providers and be able to, from your configuration code, it'll tell you exactly what permissions that you need. It's on my GitHub in case you were interested in taking a look at that. But it's not really worth the effort to go into super fine detail, just because it's not something that is really well supported right now by Terraform. However, for least privilege, as far as remote state storage, that's a different matter. Now, we should always have least privilege policies, very fine-grained ones, in fact, for getting and setting state in a remote state storage. The example that we have here is for S3. Now, if you never used the S3 backend, it's just right here on Terraform. They tell you that you configure your backend in the Terraform settings block. You define a bucket, a key, a region, and then it uses a Dynamo database to preserve locking, and also uses KMS on the back end for encryption. Kind of complicated and rather long, and if you want to know how to create one of these, you can take a look at chapter 6 in Terraform in Action, where actually I go through kind of what goes into this S3 module. And the ones for the different providers are going to be very similar in function. They're going to have a table for doing locking. They're going to have some place to blob storage to be able to put the state files, and then some way of encrypting it at rest. So when you deployed it, you want to also create roles for the people that are going to be consuming those consuming those state files and interacting with them in some way. So for example, you might create a policy that allows somebody to read S3 buckets and be able to put and get objects, maybe only from a particular folder in that Terraform state bucket. So if they were part of Team 1, then they could access the Team 1's state files, but they couldn't access other people's state files. And these S3 backends are so cheap that you might as well have one per each team and not even have to worry about creating some of these least privileged policies. But even if you weren't using S3, let's say you're using Terraform Cloud, there's still different ways that you can create least privileged on your state files, and also just in general access to your workspace. I think Terraform Enterprise does it pretty nice. You can create, they had a recent patch a couple months ago that allows you to create pretty fine-grained access control policies for your workspace, that you can say, like, if someone's part of a particular team, they have these permissions or not. You can blacklist and whitelist different users, and it's pretty fine-grained. I'm very pleased with how it turned out. The final part, as far as the state file is concerned, is that you want to enforce encryption at rest. So again, this is really something that comes already with most backends. You have S3, it's going to be encrypted at rest because of KMS, and you can define exactly what KMS key you want. You want to use your own KMS key, that's fine, but it should definitely be encrypted at rest. And sometimes you could even do a double encryption. I know that Terraform Enterprise does a double encryption where they use KMS to encrypt it once, but then they use Vault to encrypt it a second time. So that can actually make it very, very difficult to read state files that you don't have access to. Even if you had admin privileges to the AWS account that the state files lived in, you still wouldn't be able to read them because it's gibberish unless you had both the KMS key that you can decrypt it with, as well as the vault token. So it's not very reasonable to assume that you could do that, and that would make it very safe for securing your state files. Also, just so you know, the Terraform Enterprise doesn't really do anything too much different than creating your own backend. In fact, their backend is actually is whatever cloud you're going to be using. So if you're using AWS, then they're also using S3 to store your state files. It's not any different than if you're using the S3 backend. But they do provide some additional tools that make it easy to interact with your state file besides just S3 backend. In fact, I think that they have some their own custom logic built in. So it's not like they're exactly the same thing. And you don't really have to worry about encryption in transit because pretty much all of these providers, except for maybe the HTTP provider, are going to be transmitted over HTTPS, SSL, TLS. And so you don't really have to worry because they're going to be encrypting your data while it's traveling through the internet. Finally, one last thing I wanted to mention about Terraform and securing Terraform state files is that there's this people always ask this: why don't you just remove the secrets from Terraform state entirely? And this is something that's been tried in the early days of Terraform, where they would give maybe some provider or maybe some resource would define a encryption key that you could use to encrypt the sensitive information before it gets stored in the state file, and then it uses the encryption key again to decrypt it. The problem is that people would lose their encryption keys, and then they would no longer have access to their infrastructure that they deployed. Also, it made it pretty difficult for calculating diffs of state, because if your encryption is not the same, especially if you're using different kinds of encryption keys, if you're rotating your encryption key, it's not going to be the same every time, which could cause some problems with Terraform, because what's stored in state is not actually what the information is. So they just did away with that, and now they assume that your remote backend is going to encrypt all data, and that's the recommended approach if you ask anyone from HashiCorp. I have heard that, they might bring something like this back eventually as part of the Terraform 1.0, but I don't even know how they would do that. I don't think they really know how they would do that. It's a very tough problem to solve because, ideally, if you could just remove all secrets from Terraform state, then you wouldn't even have to worry as much about where you store your state file or anything like that. But I would just still recommend caution and just good planning too. So if you're going to use Terraform state, just do it right from the beginning.